Alright guys, in this part we're going to focus on booleans and the comparison operators in Python. So just as a refresher, a boolean is simply true or false. That's the only values that a boolean variable could store. They're going to be very useful in the future when we work with things like conditions, because we can do stuff like, if this is true then do this, if this is false then do this, if this other condition is true then do this, all kinds of cool stuff like that. Very, very powerful. So having an understanding of what booleans are and some of the basic ways that we can create booleans using comparison operators is very essential. So we can start with has swag. So if I just have a variable has swag, I can set that to true, or I can set it to false. That is it. It cannot be anything else. Usually though, you're going to derive your boolean from something else, such as a comparison operator. The comparison operators are just things that you always use in math. So equals, not equals, greater than, less than, greater than or equal to, and then less than or equal to. These are the basic comparison operators that you would use in math as well as Python. So using these will give us booleans that we can use. So let me show you what I mean. So first of all is equal to, otherwise known as double equal sign. We'll start by doing this. So 5 equals 5, 5 equals 5. So we're simply trying to run this condition here, this comparison operator, to see what it returns. So let's run it and see what we get. There we go. We get 5 is equal to 5 is true because 5, of course, is 5. Whenever you are using the comparison operator for equals, make sure it's double equals and not single equals. The single equals is only for assignment. So if you're like assigning a variable, you can use single equals. But for comparison, you're using double equals, okay? So if I do 5 and 6, obviously that's going to be false, so it returns false. So that's one example of how we can obtain a boolean, and that's through a comparison operator. Now here we're just directly comparing number literals, but we can use variables as well, obviously. So we could say booty is equal to 5, and then if 5 is equal to booty, if booty has 5, we know it does, it should be true. So if we run this, we get true, nice. Or if it's 56, we get false. And this could be another variable. It can even be itself. So is booty equal to booty? Obviously, that's always going to be true. Or you could say booty2 is equal to 2. That's going to be false. There we go. So that's equal to. So now we also have not equal to, which is done by the symbol of exclamation point, equal sign, not equals. So we could do that one by doing, for example, 5 is not equal to 3. So we know that 5 is obviously not equal to 3. So we can do 5 not equal to 3, and this should return true. There we go, we get true. If we copy this, and let's do it again with 5. 5 is equal to 5, so this will return false. So 5 not equal to 5 is false. There we go. We also have greater than and less than. So greater than is this one here. So if 5 is greater than 3, this will return true. Of course, that's the case, so true. And then is 3 greater than 5, that's obviously false, it returns false. And then for less than, it's this one here. Is 3 less than 5, that's true. Is 5 less than 3, that's false. Very simple. We also have greater than or equal to, so 5 is greater than or equal to 5. They're actually equal, so that's covered by that, so that's true. Is 5 greater than or equal to 3? That's true. Is 3 greater than or equal to 5? That's false. And then you have less than or equal to. So they're all very basic. This is something that should be very familiar to you outside of programming. Now, up to this point, I've only been using these comparison operators on whole numbers or ints, but we can also use them, of course, on floats. So we could do 5.0 is equal to 5. That's going to be true. But 5.2 is obviously false, so pretty self-explanatory. But then you also have strings, so you can also do string comparison using the same exact operators. So we could say if we have name1 is equal to Billy and name2 is equal to Bob, these are obviously two different names. So if I was to do print name1 is equal to name2, this would obviously be false. Let's run it. There we go, we get false. But if I change Bob to Billy, now it's true. Easy peasy. You can of course also use not equals if you want to. So is name1 not equal to name2? They are the same, so this should be false. It is. Now when it comes to greater than and less than, when it comes to strings, it's a little bit different. Characters inside of strings are based on something called Unicode, which is a universal standard for computers to represent text from basically every single language out there. It's a huge, basically a dictionary of all the characters that can exist in every language. So a subset of that is something you may have heard of, which is called ASCII, which stands for the American Standard Code for Information Exchange. So there's this table here that has all the characters that we would use on an American keyboard, everything that you would need to type. And so Unicode has this inside of it, but it also has every other language as well. This is only for America, so you can imagine it's very limited compared to every other language out there. But since I'm American, and I'm assuming most of my audience is using an English-based keyboard, this should be good enough to focus on. I think if you understand the basics, it should be fine. You can also just look up the Unicode table. It's just the same thing as this, but much larger. So what we've got here, let me break it down here, is we have all the characters, right? Like I said, so we have a bunch of characters that we don't really see, like a backspace, null, but we also have characters that we are familiar with, like these symbols, space, numbers, uppercase characters, and lowercase characters. And then for each of the characters in red, we have a corresponding decimal number, which is the number system that we use as human beings. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are other number systems out there like hexadecimal or octals, but we don't care about that. So every single character has a corresponding number associated with it. This is relevant for us because when we're comparing strings within Python, we're essentially comparing the numbers behind it, not the letters themselves. So for example, if uppercase A is 65 and uppercase B is 66, B is greater than A. And so D is greater than A, D is greater than B, and so on, right? But then you also have lowercase letters, which appear separately from the uppercase ones, and these have higher numbers. So this means that lowercase a is actually greater than uppercase A, and lowercase b is greater than uppercase B, and so on. And that's basically all there is to it. You just have to know that every letter that we represent in a string has a number associated with it, and that also tells us when we compare the strings which one is higher than which one. So let's go back here and just take a look. You don't have to study the ASCII table at all. It's just important that you know that. So if we come back here, let's just say that we have something simple like A and A. We learn that A comes higher than uppercase A. So if we do name1 is greater than name2, that should be true. There we go, we get true. And if we flip it, that'll be false. Nice. So if I was to do apple and then apple, these are identical except for the first letter, right? The first one uses lowercase a, which is higher than the first one of this one, which is uppercase A. So name1 is still greater than name2. There we go. Now, generally speaking, when you have two different words that are completely different, what you could do is count each individual character, but that's kind of, it's kind of cumbersome. You don't want to do that. A general rule is just go by the first letter. So obviously A comes before B, so beans will be higher than apple. So this will be false because name2 is greater than name1. So let's run it. There we go, we get false. So that is how you compare strings in Python. You don't have to memorize the ASCII table or anything like that. It's just important that you know what's sort of happening behind the scenes so that if you try comparing two strings using greater than or less than or greater than or equal to or less than or equal to, you know what's happening. You're not like, what the hell is happening? So that's actually it for this part for Booleans and comparison operators. Now that you know how to use comparison operators, we're going to see how we can make Boolean expressions and use Boolean logical operators in the next part. So stay tuned for that.